All right, so are you ready to dive into a question that's really kind of mind-blowing? Today, we are tackling what came before the Big Bang. It's one thing to talk about, the universe being born, but what was even there before the party started?
It's the ultimate mystery, isn't it?
Yeah.
And thankfully, we've got some help wrapping our heads around it. You guys sent in this awesome bright side video, Who Created Nothing Our Universe Formed From. And let me tell you, some of these theories are straight out of science fiction.
Yeah, they're wild. But the video does a great job of setting the stage, taking us back to the basics with Edwin Hubble and his game-changing discovery. It's like the ultimate aha moment in astronomy.
Totally. So picture this. It's the early 1900s. Hubble's on Mount Wilson peering through his telescope at these blurry patches of light. Back then they thought these were just nebulae, clouds of gas within our own galaxy. But Hubble, he proved they were something way more significant. Entire galaxies, vast islands of stars way, way out there.
Talk about a reality check. Suddenly the universe got a whole lot bigger, right?
Exactly. And it gets even wilder. Hubble noticed that the light from these distant galaxies, it was stretched, redshifted. And the further away a galaxy was, the more redshifted its light seemed to be.
Okay.
And that told Hubble something incredible. The universe wasn't static, it was expanding.
Whoa.
It's like baking a loaf of raisin bread. As the bread rises, all the raisins spread out. It's kind of like what's happening with our universe, with galaxies taking the place of those raisins.
Okay, my mind is already blown and we're just getting started. So, the universe is expanding. Does that mean if we, hit rewind, it all crunches back down to a single point?
You got it.
Is that the Big Bang?
That's the prevailing theory, right? That the universe as we know it began from this incredibly hot, dense state billions of years ago. And that initial state, which the video calls the singularity, that's where things get really interesting. And by interesting, I mean our current understanding of physics basically just throws its hands up in the air.
You mean it's like dividing by zero on a cosmic calculator? It just breaks down?
Pretty much.
Yeah.
We can trace the expansion back to a certain point. But that very beginning, that singularity, it wasn't like a tiny ball of stuff just waiting to explode.
Right.
It's more like trying to imagine all of space and time compressed into an infinitely small point. Okay.
It's a concept that pushes the very limits of what we can even comprehend.
For sure. Okay, so the universe wasn't like this tiny little ball of stuff.
No.
It was a point where space and time just kind of ceased to exist.
Yeah.
My brain already needs a break.
It's a lot to take in.
But I gotta ask, if the Big Bang started from this perfectly uniform point, how come the universe isn't just this big random mess?
Right.
The video uses that analogy of a paint-filled balloon exploding.
Yep.
Shouldn't the universe look like some crazy Jackson Pollock painting?
Well, that's a great question, and it puzzled cosmologists for a really long time. Because the universe, on a grand scale, is surprisingly uniform.
Okay.
We see this in something called the cosmic microwave background radiation. It's like this faint afterglow of the Big Bang, baby pictures of the universe.
Oh. And those baby pictures show a really even distribution of energy.
So how do we get from this tiny, chaotic point to a universe where, everything's spread out so evenly?
That is where things get really wild. And this is where this bright side video, it introduces this mind-bending concept of inflation.
Inflation?
Yeah. So picture that paint-filled balloon you mentioned.
Okay.
Instead of just exploding, imagine it suddenly inflates to billions and billions of times its original size. And I mean in a fraction of a second.
Wait, are we talking faster than the speed of light fast?
Faster. Now, I know what you're thinking. Nothing can travel faster than light.
Right.
And you're right. But there's a catch. That speed limit, that only applies to things moving within space.
Okay.
Inflation. That's talking about the expansion of space itself.
So space gets a cosmic speeding ticket, but it's okay because it makes the rules.
Basically.
That's pretty convenient. Okay, so it's like we're stretching that paint splatter across this giant canvas.
Exactly. Inflation took those initial tiny quantum wrinkles, and we're talking smaller than an atom.
Okay.
And it stretched them out across these unimaginable distances. So these minuscule energy fluctuations, they became the seeds for all the large-scale structures of the universe.
Yeah.
Galaxies, clusters, the whole cosmic web.
Okay, that's mind-blowing when you think about it. We owe it all to a cosmic growth spurt.
Right.
But this Brightside video doesn't stop at just one universe, does it? They had to throw in the idea of a whole multiverse.
Of course they did. It's a concept that's both fascinating and incredibly difficult to even wrap your head around.
Yeah.
The idea that what we think of as the universe
right.
might just be one of many. And I mean, perhaps infinite universes all existing at the same time.
Infinite universes.
Yeah.
Okay. Talk about things that make my head spin. But the video, it kind of glosses over how we even get multiple universes. Where do they come from?
Well, there are actually several different theories about what a multiverse might look like, how they might arise.
Yeah.
One model that the video touches on is the cyclical universe, an idea put forth by physicist Martin Bojowald.
Okay, so what's the story with the cyclical universe? Are we talking like reincarnation, but for the cosmos?
Kind of.
Okay.
Bojowald's model suggests that the Big Bang wasn't a one-time event,
Okay.
but part of this endless cycle of expansion and contraction. Imagine a universe, right?
Yeah.
It expands for billions and billions of years.
Yep.
And then, under the pull of its own gravity, it begins to contract, collapsing back in on itself until...
Boom! Another Big Bang happens, kicks off a new cycle.
Precisely. It's like a cosmic heartbeat,
Wow.
with each cycle potentially giving rise to a new universe, maybe even with slightly different properties each time. But here's where things get even weirder.
Okay, does it get weirder than infinite universes?
Oh, yeah.
Okay.
Bojowald's work on quantum time suggests that time itself might not be perfectly smooth and continuous as we experience it.
Wait, you're telling me time might be lumpy?
In a way, yes. Bojowald proposes that at the quantum level, time might be quantized, meaning it occurs in these incredibly tiny, discrete steps. It's like the difference between like a smooth ramp and a staircase.
Okay.
Instead of time being this flowing river, it's more like a series of cosmic snapshots.
A very, very strange set of snapshots.
Very strange. And this leads to a fascinating possibility. If time has this kind of graininess to it, then our Big Bang. It might not actually be the absolute beginning.
Whoa.
It could be just one step in this infinitely long staircase.
Wow.
A transition point from a previous phase of the universe's existence.
Okay, you're messing with my perception of reality now.
Yeah.
A universe with no beginning
Right.
and no end. That's both terrifying and awe-inspiring at the same time.
Okay, I need a minute to like process this whole time staircase thing. It's like, if our Big Bang isn't the beginning, is every day just Cosmic Tuesday?
Well, we don't have the answer to the whole Tuesday thing, but you're definitely grappling with some pretty big questions here. And it gets even weirder. Remember how the Bright Side video also explores this idea of colliding universes? Oh, yeah. Like a cosmic demolition derby up there. I gotta admit, when I first saw that part of the video, I thought they were messing with me. But there's actual science behind that.
You better believe it. It's called Brane cosmology, and it's the brainchild of physicists Neil Turok and Paul Steinhardt. Imagine our universe, everything we know, is like a sheet or a brain floating in a higher dimensional space.
So our universe is like a giant cosmic bed sheet, and there are other bed sheets, universes floating out there.
It's a good analogy.
And sometimes they like bump into each other.
Exactly. These brains, these universes, they exist in a space with more dimensions than the three we experience. It's hard to wrap our heads around because, I mean, we can't visualize more than 3 dimensions.
Right.
But mathematically, it's possible.
Okay, I'm going with the math on this one. But let's just say these universes collide. What happens? Is it like a giant fender bender?
Kinda.
We get a new paint job out of it?
You could say that. Turok and Steinhardt, they propose that when these brains collide, the energy of that collision, it's so powerful that it could spark a whole new universe, like striking a match.
No.
That initial burst of energy creates a whole new set of stars, galaxies, maybe even life.
That's a lot to take in. I mean, it's humbling, to think about how much we don't know about the universe, about how it began. We've come a long way since Hubble looked through his telescope and realized that the universe was expanding.
Yeah.
But these theories about what came before, or if there even was a before, it makes you realize how vast and mysterious it all really is.
It's a humbling experience for sure. And while it's easy to get caught up in how mind-blowing these theories are, we got to remember they are just theories. Scientists are constantly searching for evidence to either back up or, disprove these ideas.
So the cosmic jury is still out.
Exactly. It's like we're putting together a giant jigsaw puzzle, but we don't have the box, and we're still finding new pieces.
Oh, wow.
But that's what makes cosmology so exciting. It's like a constant search for knowledge, a journey with no real destination in sight.
And it seems like every answer we find just leads to more questions,
Always.
which I guess is a good thing.
A bad.
Otherwise, we'd be out of a job.
That's the beauty of science. It isn't about having all the answers. It's about being okay with the unknown and asking those big questions.
Exactly. So, to everyone listening, next time you're looking up at the night sky, remember that you're looking at a mystery that's billions of years old. And who knows, maybe somewhere out there in all that vastness, there's another you looking up and wondering the same thing. Keep exploring, keep asking questions, and keep looking up.